This would be pi over 2 minus pi over 4 rads. It's rads. Divided by 5 minus 0. That would be the pi over 4 rads. Divided by 5 seconds. That is point, but you can do, write the numerical value for pi, which is 3.14. 3.14 divided by 4. Fill out the calculator, please. 3.14 divided by 4. 3.14 divided by 4. That's approximately 0.75. 0.75 divided by 5.
0.78.
Huh?
0.785.
Divided by 5?
Huh?
Divided by 5.
Divided by 5. 0.157.
0.16. So your angular velocity would be 0.16 radians per second. Radians per second. That's the unit for angular velocity. What's the unit for this velocity? Meters per second. So that's one way you can distinguish between the velocity. Are you with me? Yes. So that's an example. Now, erase. So, what's the relationship between, you guys done right here? Finished?
Yeah.
All right. I'm trying to cover this real quick because you guys need to practice. Now, what's the relationship, what do you think the relation is between this and this? Is there a relationship? Yes. It turns out that D is equal to R times that. It also turns out that V is equal to R times that. What is this again? What is this? Theta representing what? Angular what? Angular velocity, right? There's a relationship between the linear velocity and the angular velocity. There's a relationship between the linear position and the angular position. Are you with me so far? Are you with me so far? Yes. With me. There's also a relationship between the angular displacement and the linear displacement. What do you notice? Do you see a pattern? What's the pattern? The relationship is the what? The radius of the circle. Relation. All right. So we have gotten angular displacement, angular velocity. Let's look at angular acceleration. How do you think we define? Well, let me back to it. How do we define acceleration? Average acceleration. Linear acceleration. How do we define it? Changing what?
Why'd you give me the wrong one?
Changing velocity over.
Give me the wrong one. I wasn't going in.
So how do you think we're going to define angular velocity? Angular acceleration. Change in what? Angular velocity over change in time. Okay? And so, if we have a problem, let's do an example. Let's say our initial angular velocity is 3 radians per second, and our final angular velocity is 5 radians per second, and our times remain the same, then our angular acceleration will be final minus initial, final minus initial, 5 radians per second minus 3 radians per second divided by 5 seconds minus 0 seconds. It's going to give us 2 radians per second divided by 5 seconds. That's going to give us 0.4 radian per second squared. Radians per second squared. Radians per second squared. Does it make sense? It's acceleration.
Yes.
Okay, so let's summarize. What have we learned? I'm going to summarize real quickly so you can see clearly. Linear, angular. Okay? We have position, displacement, velocity, acceleration. Right? Position, displacement, velocity, acceleration. And displacement is changing. Displacement is the final, and it's the initial. This right here is changing velocity over changing time. Changing position over changing time, changing velocity over changing time. That's all linear stuff. Right? And over here, we have angular, position, angular, displacement, angular, velocity, angular, acceleration. This right here is final minus initial. This is change over changing time. This is change in omega over change in time. Okay? Linear, angular. Now, there are relationships between these two, linear and angular. Okay? D is equal to R theta. So if I know D, I can always find this. Or if I know this, I can always find that. All I need is the radius of the circle. Right? What else? All of them are related by